Hello, my name is Steven Analaki Kunalan. My metric number is B082010-280. Today we are going to see about the tension of a spring. This is a single spring. We can set up a spring like this, or if more than one spring, we can set up in parallel. This is parallel setup, and this is a series setup. Today we are going to see the response of a spring when an external agent changes its equilibrium length when it is in a series condition. Okay, now we are going to set the left spring, this one, as 200 Newton, and the right string we are going to set up as 250. Here we can adapt the tension of the spring. Like here I'm going to set up into 250 nanometer, Newton per meter, and this one is the applied force. As the initial state, we are using the 0 Newton, and when it is the applied force is in 0 Newton, the tension of the spring is also at 0 meter. Okay, now when we are going to see what will happen when the force is applied to the spring. Okay, now we are going to apply 10 Newton of force. Okay, when we apply 10 Newton of force, the tension of the spring becomes 0.090 meter. Then we are going to add the force to 20 Newton, and it becomes 0.180 meter. The tension of the spring becomes 0.180 meter. Let's say we added some more 10 Newton of force. So when it's become 30 Newton, the tension of the spring becomes 0.270 meter. Here we can see that when the force is increasing, the tension of the spring also will increase. So we can continue. If let's say summer 1 we see 40 Newton, if we set up to 40 Newton, the length becomes 0.360 meter. If 50 Newton, here we can get 0.45 meter of tension spring. And finally for 60 Newton we can get 0.54 meter for the tension of spring. Okay, just now we see what will happen if the applied force is increased. Now we are going to change the left spring and right spring's tension. It means we are going to increase the tension of the spring. Okay, now we take the left spring, we put it 250 Newton per meter, and the right spring we put 300 Newton per meter. Okay, now let's check. Okay, now when the force is 0 Newton, the tension of the spring still same, 0 meter only, and now we are going to apply the force to the spring. Okay, let's say we apply 10 Newton. Okay, when we apply 10 Newton, the tension of the spring becomes 0.073 meter. And let's say we increase to 20 Newton. Okay, when the applied force is 20 Newton, we can see here 0.147 meter of the tension of the spring. And let's say we see for 30 Newton, we are getting 0.220 meter. And we also can compare just now when the tension of the spring is small, and now it's bigger than it's more tension. We are using the more tension spring than the earlier. So we can see here just now for 30 Newton, we just get 0.270 meter, and now we are getting 0.220 meter only. So here we can see that the length of the spring is decreasing. Let's say we see for 40 Newton. Okay, when it's 40 Newton, now we are getting 0.293 meter. Just now we get 0.360 meter. Here also we can see that just now value is smaller than just now value is bigger than now. So here was some more one thing. Here also the same thing happened, which is when we are applying we are increasing the applied force, the length of the spring is also increasing. Finally, we can conclude that the response of a spring when an external agent changes its equilibrium length, it will increase the tension of a spring when the applied force is increased. Thank you.
Next is part B. Part B is about tension springs connected in parallel. Now I want to show how to set up the Hooke's law to get the length of the springs of parallel springs. First, we need to click the Hooke's law systems at the home page. Next, we need to tick the displacement and values at the box. Then we need to click the parallel spring connection. Okay, then we set up the top spring, make it 200 Newton meter, and for the bottom spring we set to 250 Newton meter. Okay, for the apply force we need to increase it until 10 Newton, and we can see the length of the spring is 0.022 meter, and when we increase the apply force we can see the length of the spring will increase because we have applied force on it. So that's all. We go to part C.
Assalamualaikum. I'm going to show you about Hooke's law system using a simulation. So first, what you have to do, click the displacement. We have to displacement and values. Then for the spring constant, for the first time we have to set it to 150 newtons. So 150 newtons per meter. Then for the applied force, first we will use 5 newtons. So we will get 0.033 meters, which is the length of the spring after applied force. Next, we will increase the applied force another 5 to 10. We will get 0.067 meters. Then we will add another 10. We will add another 5 newtons applied force. We will get 0.1 meters. So we will add 5, another 5, and another 5 until we achieve our results for table 1. Next, we will change the spring constant into 200 Newton per meter. So applied force, we will use same 5 Newton for the first time. We will get 0.025 meters, the length of the spring. Next, we will add another 5 Newton applied force. We will increase it to 10. We will get 0.050 meters, the length of the spring after applied force is applied. Then we will add another 5 once more, so it will become 50 newtons applied force. Then we will see the length of the spring increases 0.075 meters. So lastly, we will use the spring constant 250 Newton per meter. Applied force is the same. For the first time, we will use 5 Newton. We will get 0.020 meters, which is the length of the spring after the force is applied. Then we add another 5 Newton force to the system. We change it to 10 newtons, so the spring length is now 0.04 meters. Then we will add another 5 newton force to the already 10 newton, which will become 50 newton. So the length right now is 0.06 meters. We will continue this until the table for our lab is complete. Thank you.